Every time you unlock your smartphone, stream a video, or ask an AI assistant a question, thousands of invisible engines are working behind the scenes. These are algorithms. They decide which information appears in your feed, identify the fastest GPS routes, and detect patterns of fraud in global banking systems. While these processes feel like the cutting edge of silicon-based technology, the logic driving them actually predates electronic computers by over 1,200 years. To understand how our digital world actually functions, we have to strip away the screens and travel back to a time when mathematics was broken. In the 9th century, mathematical problem-solving was a chaotic and unstandardized discipline. There was no universal system to guide a scholar from a question to an answer. Scholars were forced to rely on guesswork, intuition, or memorized examples. If a new variable was introduced, a method that worked yesterday might be completely useless today. The field lacked a repeatable how-to guide, a way to solve problems that worked the same way every single time, regardless of who was doing the math. Without a universal, repeatable procedure, complex calculation at a massive scale was impossible, placing a hard limit on human progress. Working in Baghdad, a mathematician named Muhammad ibn Musa Al-Khwarizmi realized that teaching isolated answers was an evolutionary dead end. He introduced a different approach, a systematic sequence of steps capable of solving an entire class of problems rather than just one specific instance. This is the algorithm's logic. It takes a complex problem and disassembles it into a top-to-bottom sequence of distinct instructions. Follow this exact logical order, and you guarantee a correct solution. The starting numbers might change, but the procedure remains the same. This repeatable sequence, the shift from guesswork to a guaranteed procedure, is the very definition of an algorithm. In the 12th century, European scholars began translating Al-Khwarizmi's Arabic texts into Latin, bringing his methods to the West. These translations introduced his procedural approach to a new audience, but the translators Latinized his name to algorithmy. Over the next few centuries, algorithmy morphed into the word algorithm, which was used specifically to describe calculations performed with Hindu Arabic numerals. As mathematics continued to evolve and modernize, the term underwent one final transformation, becoming the word we use today, algorithm. The literal name of the scholar became the permanent label for his methodology, linking the inventor to the concept forever. By the 20th century, the invention of electronic computers provided a powerful new environment for these procedures to run. It's a common misconception that computers invented algorithms. In reality, they simply provided the hardware to execute Al-Khwarizmi software. The difference was scale. These machines were built to follow the same step-by-step logic, but they could do it billions of times per second. This massive escalation in speed allowed algorithms to move beyond basic algebra to tasks like guiding spacecraft through the precise maneuvers of orbital flight. All of that raw computational power is useless without the structural integrity of the 9th century logic that tells the machine exactly what to do. Today, that same logic is at the edge of human achievement, powering everything from AI learning patterns to the search engines that index the entire internet. The terrifying complexity of modern technology is actually just an immense layering of simple, logical, step-by-step procedures running simultaneously. Every time a modern processor hums into action, it is executing the legacy of Al-Khwarizmi, proving that the way to solve an impossible problem is to take it one logical step at a time.